Hello everyone, I am Dan Nault, and I lead migrations in AWS database services. I'm excited to meet with you today to talk about how you can break free from legacy commercial databases to save, grow, and innovate. I'm glad to be joined by Dmitry Zilberg, the Chief Technology Officer from our customer FactSet, who has joined me to share their journey breaking free from Microsoft SQL Server to Amazon Aurora. Now, to look at our agenda. Companies of all sizes, including Amazon, have felt constrained or otherwise frustrated by their commercial-grade database relationships for decades. They ask for capabilities like commercial databases have, but also want the benefits of open source. And AWS provides that both in innovation and in low price. Amazon Aurora, the name of the Roman goddess of the dawn, provides this capability, open source compatibility, and low price with both Postgres and MySQL compatibility. And more broadly, AWS leans in to help you break free from the old guard with innovation in target services and tools, experts in training to help accelerate your migrations and help you focus your teams on your unique innovation, and programs to help you, including with AWS professional services and our partners. Then Dmitry will share their experience breaking free from SQL Server to Amazon Aurora. We'll then close on next steps to help you get to database freedom. So let's get started. Many existing applications are built on legacy databases, and customers have had to deal with old guard database providers that are expensive and proprietary, designed to lock you in technically and in business terms, and impose punitive licensing terms, and then use audits for punishment and as a deterrent. As an example, a few years ago, Oracle announced that they would double their licensing price when you run their software on the exact same processors that Oracle uses, but instead run on AWS or Microsoft. While they might argue they're legally allowed to do that, whether they can or not doesn't make it right. To provide a sense of how motivated customers are to break free, since we launched the service, over 350,000 databases have been migrated to AWS using the database migration service. As to why? Commercial databases are expensive. And it's not just the sticker price. The tremendous cost of commercial databases is far from customer obsessed. And it's not just the initial sticker price. The entire business model of commercial databases comes at the cost of painful customer expense. And to look deeper at reasons why, the licenses are restrictive in a way that's designed to increase your cost. Commercial database licensing has old world tiering that presents barriers to elastic scaling in the cloud. You have to change licenses to scale up or down. And while elastic scaling is provided for commercial databases in the cloud sometimes, it's very costly so that they control how it competes with their traditional licenses. And those vendors watch this like hawks, with monitoring that they might say is for support, but they use it for tracking and then painful audits when they smell money. Shifting from cost to innovation, the AWS strategy is to have exactly the right tool for the job to be done. Our collection of purpose-built databases is unique. You won't find this collection anywhere else. And if a vendor tells you, oh, no, you don't need that many databases. I have a relational database that's powerful and mature that can do all of this, and also a non-relational if you really want that. They can take care of all of this for you. Well, not quite. Or if a vendor tells you, no, I have a non-relational database, and it does key value really well, it does document really well, it does graph really well, and it does time series really well. Well, the physics of computer science says differently. Swiss Army knives are hardly ever the best solution for a specific task. If you want the right task for the right job that gives you differentiated performance, productivity, and customer experience, you want the right purpose-built database for that job. And in many cases, you might be moving from or to an analytics system or services. The same is true here. We similarly have a family of purpose-built analytics services across ingestion, processing, building data lakes, analytics, and prediction, such as using ML. You might use Glue or Lake Formation to build a data lake, Athena for ad hoc queries, or Redshift for a data warehouse, as examples. For specifically your relational database needs, I do want to share why we spent a few years building Amazon Aurora. Amazon Aurora is a MySQL and Postgres compatible relational database built for the cloud. It combines the performance and availability of high-end commercial databases, but with the simplicity and cost-effectiveness of open source databases. Aurora has 5 times the performance of standard MySQL and 3 times the performance of standard Postgres, with the security, availability, and reliability of commercial databases at 1/10 the cost. Just to dive deep for a minute, with Aurora, there are 2 core innovations that come from us looking at the storage and I/O infrastructure of open source, which is decades old, and instead leveraging the power of AWS infrastructure. Unlike traditional databases, which write both logs and full pages, we just have to write logs. That means much less network I/O, less work on the engine. And instead of the heavyweight distributed consensus for data replication that's typical, we use AWS infrastructure to maintain order for much better performance. And Aurora stores 6 copies, 2 copies for each of 3 availability zones, with instant database redo recovery. This innovation means you don't have to trade off performance, availability, and durability. And all of that means that Aurora customers are saving money. It is far more cost-effective than commercial databases. In one example, our partner House of Brick did a detailed analysis of how they helped a large customer achieve a 301% savings over Oracle Enterprise with Aurora Postgres. In another example, IDC found up to a 264% 3-year ROI with 39% lower 3-year cost of database operations and a 5-month payback period. Truly compelling. And to share some specifics about database freedom, there are 3 parts to our strategy. First, in technology, we have purpose-built databases and analytics services to meet your business needs, and innovative migration tools with high automation to reduce manual effort. In expertise, we extend your talent with AWS solution architects, AWS professional services, systems integrators, and training and certification for all of your teams to help speed your migration by leveraging proven practices and guidance. And we have programs to reduce risk and the cost of migration with workshops, proof of concepts, pilots, and partners. And these all create a strong migration business case with AWS relative to legacy database vendor costs. With that, please let me introduce Dmitry Zilberg, the CTO of FactSet.
Dan, thanks for that intro, and thanks for having me as a co-presenter for this great session. I'm excited to participate. So my name is Dmitry Zilberg, and I'm the CTO over at FactSet, and I'd like to begin by spending a minute or two by talking about our company and providing some background. So FactSet is a provider of financial market data and analytical tools. We have over 133,000 users around the world of our products. FactSet was founded in 1978, so it's just a few years younger than I am, and we happen to share a birthday month. Some of you might be wondering why there's a picture of a biker on the slide. I am a big Peloton fan, but that's not why. And as I go into some of the details around how we're using Amazon and how we're using the database freedom programs at FactSet, I wanted to establish some context and background by talking about our roots in technology and our background as a company. So, as I said, FactSet was founded in 1978, and our name, FactSet, hails from the first name of our product. So, in the late 70s, we delivered our product, which was a single sheet of financial information about public companies, every morning to our financial customers via bike messengers. And that one pager was called a FactSet, right? A set of facts. Our tech journey began with mainframe computing. In the late 70s, we used mainframe computing to generate the data. And then later in the 80s, we began to use mainframe computing systems. At that point, VAC systems running OpenVMS as our platform. Our users would dial into modem banks connected to serial ports on the back of these mainframe computers. Would get a prompt, would log in through our software, and begin to interact interactively. So we were actually in the forefront of using dial-up as a means of delivering a product. Soon after that, we were in the forefront of using TCP networking, and we were deploying some of the first frame relay networks in the world. So FactSet's product is very much, to boil down how our product works, is it's several thousand data sets that falls into two categories. We have commercial data sets, which we gather ourselves, collect ourselves, or acquire through partnerships with third parties. In addition, there's client-generated content on our system. So commercial content or third-party content can apply to multiple clients and used by multiple clients. An example could be something like fundamentals or estimates or index data. And then examples of client-generated data can be something as simple as settings, portfolio views, or holdings information. Regardless, on top of the data, we have a number of different compute engines, analytical engines that allow our clients to perform analytics, attribution, screening, and various other capabilities. And on top of that is a user interface that we call a workstation, and that's our traditional product. We started, we like to think that we have our roots are in technology innovation, and in fact, some 24 years ago, we built our own database that we call FTB, FactSet Database. FTB is essentially a three-dimensional key value store, where a key could be, for example, in a simplified example, could be a key could be a security. Values could be pricing information or the moving average or some other piece of financial data. And the third dimension that made FTB interesting and unique is a point in time. So some 20 plus years ago, we had a NoSQL where I'm not sure that such an acronym existed, hence the roots in innovation. A little over a decade ago. So FTB was built and deployed on our mainframe computing environments on OpenVMS. And then some 12, 15 years ago, we began to pivot away from OpenVMS, from mainframe computing, and embrace distributed computing platforms such as Linux, running on commodity hardware. We began by porting FTB to Linux, which we have, and still runs in production for some workloads. But in addition to that, we also began to embrace and invest in open source and off-the-shelf database platforms. SQL, MySQL, Elastic, and other forms of data containers began to arrive at FactSet. In our mainframe computing environment, right, our developers, our engineers, in some ways, mainframes can be described as a cloud of sorts, right, where compute and storage are abstracted, right. There's a common view of all of the storage components, and there's data consistency across all nodes. And in many ways, right, resources are transparently provided and scalability is transparent. So in some ways, in abstract ways, it's a cloud. And our developer workflows were very much built around that capability. So as we began to embrace distributed computing and deploy non-FTB data platforms, we attempted to replicate some of the same attributes. So in that example, we tried using some of our very best engineers to build a PaaS database platform to drive MySQL. And we did a pretty decent job, but we quickly found that it was very difficult to do and expensive to support on our own and scale. So from MySQL, we went to a very large deployment of MS SQL with well over, let's just call it thousands and thousands of instances for key production workloads. We began to deploy MS SQL as part of this journey off of FTP and realization that running our own paths for an open source platform on-prem was not a trivial thing to do. We also found that optionality was limited, right? We could, we really only had 4 or 5 off-the-shelf data containers: Elastic, Hadoop, and MS SQL really became the primary choice for relational needs. And we were beginning to discover over the past couple of years, 5-7 years or so, that in some cases, right, we were putting a round peg into a square hole because it was difficult to continue to deploy container database platform after database platform on-prem. So as I begin to talk about how we are employing database freedom and AWS at FactSet, I just wanted to spend a few more minutes describing our digital transformation, which we began some 18 months ago. Again, DT, digital transformation, it can be viewed as an overloaded term in the industry, right? Many companies have been undergoing it for, in some cases, decades, iteration after iteration. So I'd like to spend a few minutes defining what it means and connect it to some of our technology initiatives and programs that we have at FactSet. One key component, one cornerstone of digital transformation at FactSet is to continue to invest in further digitize user workflows at FactSet. For us, that means to embrace and further invest in our existing applications, as well as to introduce new applications that meet the needs of our clients and help us expand into new markets and new segments of the financial communities. Another central piece, and this is where I'll point back to how important data is at FactSet, and in some ways it's truly differentiating among our most differentiating assets, especially when joined and married with our analytical engines, our compute engines. So in addition to offering, traditionally our clients would interact with our data and our engines through our workstation, through our user interface. But we've accelerated and began investing in APIs and other open channels as a means of our clients accessing our data and our engines. We are replicating and have begun replicating many of the capabilities that our workstation offers, but through API. And in addition, we listen to our customers and respond to their preferences for other channels for delivering our product. Right. So in some ways, I would use that. In addition to open, I would use the term omni-channel to describe our approach, where we're making our content, our data available on cloud platforms such as S3, Redshift, or other data platforms. And thirdly, the third cornerstone of our digital transformation initiative is to continue to expand and invest in content. Right? Thematically, you may begin to notice how often I refer to the importance of content and data at FactSet to our product and to our clients. We are investing in additional data sets that we believe will help us grow and again meet the demands of our client base. One such example is ESG data, and we recently acquired a great company called True Value Labs, which specializes in the content set. And underneath that three-pronged product strategy is a digital foundation, and this is where we invest in cloud, data modernization, and other forms of technology to drive these product outcomes to completion. So since this is database freedom session, I will focus on some components of our data modernization strategy. As I said, I already touched on some of the data platforms that we have in our legacy data centers, or had in our legacy data centers. Elastic had a large presence. Hadoop had a large presence. Relational had a large presence, largely on MS SQL, with some MySQL sprinkled in, left over from our attempts to build our open source platform. So as we began to embark on the cloud journey to drive the digital transformation, we certainly decided very early in the process that cloud had to be the platform, had to be the foundation, right? The scalability, the reliability, the innovation engine that it uncorks are just absolutely indispensable for us. For the database program itself, we largely chose AWS, and so Elastic, Hadoop, and our relational containers are migrating in parallel work streams to AWS. And where possible, we are attempting to embrace open source or continue to embrace open source. That was another key parameter for us. And probably most importantly, as we began to embark and move assets and modernize our data layer, it was important to us not to just move to cloud, not to just do a lift and shift, but to also modernize and re-architect where it made sense, where it was appropriate, right? So this goes back to my square peg round hole analogy, where we were limited perhaps in our on-premise technology portfolio, and we put a data asset that was not ideally well suited into a relational container or even into FTP. And the other component, the other aspect of our strategy that was apparent to us is that in order to scale and meet the desired timelines, we would need to expand and flex our capacity with professional services. So we were excited to partner with AWS ProServe on our database migration program for our relational assets, MySQL and MS SQL. We chose Aurora as the platform. It was in many ways reminiscent of what we were trying to build some 7 or 10 years ago on-prem with our so-called MySQL platform. Right, the scalability of Aurora is just incredible, right? It last check, right? You can do 15 replicas. You can seamlessly scale across multiple AZs. There's multi-region support. The availability is incredible. Right, the flexibility and the openness, right? It's fully Postgres compliant, right? So if one day we decide to choose another underlying database platform for Postgres or for MySQL, we can easily do so. So that was another key factor that drove us to Aurora. The partnership with AWS after a careful selection process was also an exciting and key component of our approach and our strategy. Specifically, we partnered with a bunch of smart folks at AWS that came from their OpenSCG acquisition, which were some of the, I think, most highly regarded Postgres smart guys and technologists in the world. And in this partnership, in this engagement, my team is closely embedded with the AWS ProServe team. And in some cases, we forget who's a FactSetter and who really carries an Amazon badge. The program is going quite well. We have migrated several dozen databases so far, and even though we're only maybe 15-20% into the program, we're doing great. We're on track and believe we'll be completed in time for our targets that we established. And with that, I will hand back to Dan. Thanks again for having me present at this awesome session. Thanks, Dan.
Thank you, Dimitri. Super exciting to hear your vision and how we are able to support you with our innovation and programs. And now I'll start wrapping up with some thoughts on next steps. To help you, our Database Freedom Program provides innovation, talent, and programs to help customers of all sizes, whether you use our self-service innovation and partners or work closely with AWS. We offer high automation and low cost. Using DMS, you can make homogeneous migrations from legacy databases to managed services on AWS, such as from Oracle to RDS for Oracle, or Postgres to Aurora Postgres. Alternatively, using both DMS and the schema conversion tool, you can do heterogeneous conversions, such as converting from SQL Server to Aurora. And as Dimitri talked about, to help you at any scale, we have AWS professional services and many migration partners around the world, trained and ready to help. To add to what we just shared, some additional resources you might find helpful include details on the Amazon Database Migration Accelerator that includes fixed price heterogeneous database conversion and migration, more on Aurora, on the database migration service and the schema conversion tool, and the AWS pricing calculator to help you see just how much you will save. In closing, I'll also invite you to check out these related sessions on migration programs and managed databases and a deep dive on DMS and SCT. With that, thank you for your rapt attention. We look forward to helping you break free to database freedom.